Today I'm going to show you how to build a linear slider motor with speed control and USB power for both time-lapse and normal speed videos for as little as $55, but for the deluxe version around $85–90. First of all, I'll just give you some of the drawbacks to using a DIY solution. For starters, it's relatively heavy. It's also less customizable than a prefabricated unit. A big drawback is that it doesn't use stepping motion, so the commercial units will do a movement stop action that ensures that each image is captured sharply, which is really only important for nighttime time lapses. However, there's a major benefit to doing a DIY time-lapse slider motor, and that is that it's cheap and it's actually pretty easy. The whole thing will only take you an hour or less to make. This is what you're going to end up with once you're finished. Here you've got your self-contained, portable, stable unit which has speed control through a pulse width modulator, which is safe, reliable, doesn't cause any damage to the motors unlike voltage control, and you can turn it down to extremely low speed, so you can make each motor run at as little as 10% of their normal operating speeds. We've got a 2 RPM motor here, which can take you down to speeds as slow as 1.5 centimeters per minute, which is extremely good. For time-lapse, you can even possibly get it a bit lower. Over on the other side, we've got a 70 RPM motor for doing normal speed motion across the slider. Switch to turn them on or off. Adjust the speed, and 2 RPM. Also, so for $55, I'm only suggesting you put in the time-lapse motor because obviously that's the most important one. For about $90, you can also chuck in the extra bits like the 70 RPM motor for normal speed. USB port up the top. Now you probably can't see it there, but it's got a USB port, 5 volts, so you can charge all of your gadgets. We're talking iPads, phones, and in my case, a fan, which might seem ridiculous, but a fan is actually extremely important to me. I've done a lot of time lapses in cold environments, and I always seem to get fog and condensation on the lens. So having a little fan which you can power off this thing, and the battery has enough charge to run this thing for probably a week or two straight. Will create airflow circulation around the lens and stop any condensation from building up. Drill chuck, which is what spools your line. Brackets are mounted onto the slider. I'm suggesting you get L brackets for flashes, which come with one of these, which allows you to screw it straight onto the slider. And over here, a little 1.3 amp hour 12 volt battery, which will last a ridiculously long time, and is actually kind of useful in the field for charging your bits and pieces with the USB power. So this is what it's all going to end up looking like. For $55, you can do it without the battery. Now the battery, you don't need a battery. You can run it off any old 12 to 14 volt thing. I'm suggesting a drill battery, a battery powered drill battery, and so for $55, scrap USB, scrap 70 RPM, use your own battery, and you can have a time-lapse motor with speed control. For about $85–90, chuck in the normal speed motor, put in USB, little fan, and a dedicated battery for the unit. Alright, so the final thing that I did with this little project was, since I'm reasonably handy with a sewing machine, jump on and make a little carry bag for it. To start with, I'm just going to tell you about some of the parts that you'll need to make this. Here we have a 12 volt DC 2 RPM, that's 2 revolutions per minute, geared high torque motor. This is what will do your time-lapse motion. Over here we've got a 70 RPM 12 volt DC geared motor. Now in hindsight I'd say go 60 RPM and get a high torque version. This is what will do your normal speed motion. Up here at the top we've got a 12 volt USB unit that will allow you to power things. In my case, I was particularly interested in running it for a small USB fan, which I can then use to circulate air in front of the lens, which stops condensation building up, which I've had a lot of trouble with doing time lapses in cold climates. So this is a 5-volt unit, can also charge things like your phone, your iPad, anything that's USB powered. But in my case, I was interested to run a little fan off it, which gets circulation around the lens and stops the build-up of condensation. If you choose to, you'll need a 12-volt battery. Now, any 12-volt battery will do, but in this case, I used a small little 1.3 amp hour unit. Now, 1.3 amp hours is actually a lot of battery power. 1.3 amp hours will run that little USB fan for about probably a week straight or more. It'll also give you a lot of run time on your motors. Now, what pulls it all together is this, which is a standard drill chuck. Now, the chuck goes onto the shaft for each motor and can easily be changed. Here you'll see some fishing line, just normal fishing line. In this case, I've used braided because it doesn't have memory, so it just holds around the chuck a bit easier. And so you'll be attaching the chuck there. Here we've got a little beam that supports, that's got 2 guides. Now what these do is feed the line through onto the drill chuck, but at the end I'll tell you a better way to do this. Of course, one thing to note is that this is the first time I'd made it. In hindsight, I would have done things a little differently, and I'll tell you about how I would have done it a little differently at the end of this tutorial. Down here we've got an L bracket. I used a big heavy steel unit, but if you were doing this, I'd recommend you just get 2 L brackets, which are normally used for flashes. They're cheap as chips, and I'll give you a link to buy them shortly. Holding down the motors, we've got just some brackets. They're normally used for PVC pipe, cheap as chips. One thing I should note is that I put a bit of foam underneath them to give them a bit of extra grip on the motors. It's all contained inside a jiffy box, which is just a tough plastic container. And on top of the jiffy box, we've got something called a pulse wave modulator. What this does is control the speed by turning the motor on and off so quickly that you can't even notice it. It means that it doesn't cause any damage to the motor, and really effective way of slowing down the speed of these units to whatever you desire. And we've just got 2 little switches, one that just does on off. I use that to turn on and off the USB, and another one here which does on, off, on. So that will switch between the 2 RPM and the 70 RPM motor. The last thing that you'll need is a 1N5404 diode. These cost all of about 20 cents. And the reason you'll need one of these is because when you're using a pulse wave modulator, which is what we're using to control the speed, when you turn down the pulse wave modulator really low, so it's going extremely slow, the actual motor itself, if you stall the motor, you can get a spike of voltage, and what this will do is just stop that back spike of voltage from doing any damage. To build this time-lapse motor, you're going to need a few tools, and I'll just assume that you have these things. You'll need a drill for starters. You'll also need some spade bits. You'll need a pair of pliers, preferably a soldering iron, although you can do it without it. It's just a little more difficult. Ideally a Dremel or even just a file would do. The only reason you need that is because I had to grind down some of the little raised edges in the jiffy box, which is the black unit that it's all contained in, and I just had to grind those parts down to make space. Now if you're not worried about where your little parts are located, then you don't need a Dremel. Really, it's optional, and if you work hard enough you can do it with a file anyway. You'll also need a few miscellaneous bolts and screws. You'll need some wire, some cable to power the whole unit. Anything will do. You can even cut up an old extension cord and just pull the wires out of that. And you'll also need some fishing line to put on the chuck, which is what will pull the slider unit across the slider. I'll just go into a little more detail about the parts that you'll need. So I've already mentioned most of the parts that you'll need, but what I didn't mention is the total costing. Now you've got two options here. You can make a basic unit that will just do time-lapse speeds, so it won't do normal speeds, without USB power, and also without purchasing a dedicated battery. So you'll have to have some kind of 12-14 volt battery. You can run it off a car battery. You can even run it off a 14 volt drill battery, no problem at all. To do a basic unit that just does time lapses, it'll cost you about $55. Now if you want to do a more sophisticated unit that will also, and that includes speed control, so that'll do time lapsing with speed control. If you want to do a more sophisticated unit with a dedicated battery and a second motor so that you can do normal speed slider shots as well, then that'll cost you about $85, $90. A large proportion of that cost is actually just the battery, which costs a fair bit of money. I'm not going to go into great detail about where to locate each of the motors and the parts, because really it'll depend on the size jiffy box you get. I'm not saying you have to get this exact size. You can get any size you want. In fact, the smaller the better. So I put this one in a larger 200mm by 120mm by 60mm unit, but I actually recommend that you get a much smaller 160mm by 95mm by 53mm unit. I think that you'll be able to fit all of the parts in there, and obviously the smaller it is, the more portable it is, the better it is. You'll see here that I arranged the motors so that on one side there was the very slow geared 2 RPM motor to do time-lapse shots, and on the other side was the faster geared 70 RPM motor that would do your normal motion shots. Now the idea was that you'd use your chuck and you could easily change it from one shaft to the other shaft to do your shots, whether you wanted to do time-lapse or normal speed. Now, in hindsight, I don't think that was the best way to do it. If I did it again, I'd strongly recommend that you have your motors angled 90 degrees to the base and you'd have your shafts coming out the bottom. So if you think about it, your slide is here, it's running top to bottom, and your camera is moving up like this along the slider, facing out this way. It's much smarter to have the shaft coming out the bottom, and so that way your chuck is spooling the line like this, and it can be directly in front of the actual camera itself. Now one problem that I've had is that I basically have to have a guide here. So what this does, this guide feeds the line onto the spool. Now without that guide, the unit just won't work. However, if you can mount your chuck that's spooling the line underneath the unit, and to do that all you have to do is have your L bracket come out a bit lower. You can have it directly in front of the actual camera itself, and it basically means that it will spool perfectly without the use of any guide. Much better way to do it, and I think there's enough space down there to actually have both of the motor shafts coming out the bottom. So I'd definitely recommend you do that when you're making yours. It also means you can scrap this bit of metal that I've used to make the guides for the motors, reducing the weight, making it a smaller unit. One of the important steps in the process is attaching the 1N5404 diode in the outlet part from the pulse wave modulator. So, sounds complicated, it's actually really simple. Basically the pulse wave modulator is the thing which controls the speed, and the diode is what stops any damage happening to the pulse wave modulator should the engine stall because you've reduced the speed so low. In practice, you've got your pulse wave modulator here, you've got the inlet from the battery and the out from the pulse wave modulator itself going to the unit. In this case it's our motors. Flipping it over, obviously a little bit messy, but excuse the mess. We've got the outlet positive and the outlet negative, and in the middle we've got the 1N5404 diode. Now the important thing to note here is that the grey section of the diode is closest to the positive line. The long black section of the diode goes on the negative outlet of the line. So what I'm just going to do is solder those parts on, and I'll show you a little close-up after I'm done. What I've done in here is I've installed the 12 volt USB input here, which is super easy. It was just a matter of using a spade bit to drill a hole and then just bolting it down here and here. I've bolted down with a little bracket the 70 RPM motor, which of course I'm suggesting you use a 60 RPM high torque one, which will be bigger. And over here I've just bolted down the 2 RPM 12 volt high torque motor, which was used for the time-lapse, and this one used for the normal speed. Now I've just soldered those connections on. To be honest, you don't even have to do that. Believe me, I am not good with electronics. I have no idea what I'm doing, and you'll be amazing how well things can work when you really just have no idea what you're doing. So don't really worry about it too much. I soldered it on. I don't know how to solder. I just kind of winged it. I'm sure you can work it out. What we're going to do now is wire the time-lapse motor up. Now, right now, it looks like a complete mess, but I can tell you it's not as complicated as it looks. Basically, what you've got is your power coming in from the battery, which is these two lines here, and I've just drilled little holes to get that through. It comes out here. Here we've got the pulse width modulator. We've got the power coming in from the source, which in this case is going to be the battery. And then we've got the power coming out. Now the power coming out is going to go through a switch, which the switch will determine whether the power is off or going to the fast motor or the slow motor. We've got a separate switch which is going to control the USB port. Now with the pulse width modulator, we're actually running the power straight into the modulator, and then the power is coming out, and it's where the power is coming out and it's going into the switch. That's what's going to control the on-off, because our switch is an on-off-on switch, which means that it can obviously be in an off state, but it can also go and switch between the power going to whichever motor we choose, so the 2 RPM motor or the 70 RPM motor. With the USB port, we're going to run the power from the battery into the switch, and then the switch will have an on-off state for the USB port. Okay, so we now know where everything is going to go. It's just a matter of putting it all together. This cord here, as I mentioned, is the one coming from the battery. So it's the negative from the battery. Now basically we can just hook up all of our negatives together. So this is the negative coming in, this is the negative going to the pulse width modulator, and this is the negative coming from the USB port over here. We need to put them all together. In this case I've used a little crimp, but you can use anything. You can even just twist them together and put some electrical tape over the top, and that'll work just fine. The next thing we need to do is connect the positive power, and to do that we're going to take the positive from the battery, we're going to connect it to the positive into the pulse width modulator, because the power is always going to the pulse width modulator. The only difference with the pulse width modulator, the way the state is changed to go to the motors comes from the outlet from the pulse width modulator, which we're going to hook into the on-off-on switch. In terms of the USB port, we're going to run power to power straight from the battery. As I mentioned, we've already got the negative going straight to the battery, and we're going to run the positive into the on-off switch, and then we'll have the positive from the USB port going straight into the on state for the switch. I know it still looks like a complete mess, but it's actually simple, like I said before, and I'll just talk you through the wires that we've got going on here. So, the important ones. Here, we've got our power coming directly from the battery. Positive, red, negative, black. The power from the battery comes and goes straight through into the on-off switch for the USB. So it goes into the center connector for the switch, and then the power comes out to the USB port from either of the side ones, it doesn't matter. It can then be controlled by obviously flicking the switch. So power comes in, it's controlled by the switch on-off directly into the USB. The positive from the battery also comes straight through and goes into the pulse width modulator. From there, it will come out, go into the 1N5404 diode, and it will go into this switch, but I'll cover that in a sec. For now, let's talk about what our negatives are doing. So the negative is coming from the battery here. It's going straight into the USB. So negative's just hooked up straight from the battery into the USB. It's also coming straight into the pulse width modulator, which is going, so it's coming in here, around, straight into the pulse width modulator. Over here with the pulse width modulator, we'll talk a little bit about the actual motors themselves now. So the power so the positive and the negative are coming into the pulse width modulator. They're coming directly from the battery. What happens next is when it comes out of the pulse width modulator, the negative comes straight out through the 1N5404 diode, directly connected to both of the motors. So the negative comes straight out through the diode, straight to both of the motors. The last thing we have to do is connect the positive from the out from the pulse width modulator, which is this one here. It goes through the 1N5404 diode, and it will go down here into the center of the on-off-on switch, and we'll also hook up the positives for each of the motors to either side. That will then allow us to switch between the motors. Center will be off, left will be on for the 70 RPM, right will be on for the 2 RPM. Okay, so we're getting pretty close now. Everything's wired up. What we've got is just that last step, which is down here, although it's rather messy. As you can see, I'm actually no good whatsoever at soldering. You don't even have to solder it. You can just wrap it around and put some electrical tape around it. It really doesn't have to be that neat. Once it's inside, it's solid, it's not going to move around. You'll be fine. So that last step was taking the positive out from the pulse width modulator, which is this cord here, remembering that we already had our negative hooked up to go straight to the motors, and we've taken that positive out, and down here in the center of the switch we've connected the positive out from the pulse width modulator into the center, and then on either side we've got the positive from each motor coming in. So we've got the positive from the 2 RPM coming in here on the right, and the positive from the 70 RPM coming in here on the left. That just means, as you'll be able to see in just 1 second, that we'll be able to, by flicking the switch, so it's in the center position, the switch at the moment, so it's off. To the right is going to turn the 70 RPM, to the left is going to turn the 2 RPM. And you won't be able to see it, but the other switch on the right here is turning on and off the USB. So all we've got to do now is seal it all up and just jam all those wires in there. Make sure they're not touching anything. I'm actually going to cover them up in a bit of electrical tape so they won't contact anything that they shouldn't be contacting. Now, as you can see, so we've got the 2 RPM going there. You can hear that it's, so you can actually see here it's on full power here. If we turn down the pulse width modulator, while you won't be able to see the fact that it's slowing, you should be able to hear that it's no longer turning quickly anymore. In fact, by the time we've got to this point, which isn't even near the off switch, we're operating at about 15% speed. It's much more obvious when you hear the 70 RPM. So, we've got all our wires done. We've crammed them all in there. We've made sure that there's no exposed parts so that they're not going to be making contact with any metal. And from this point, it's really just a matter of sealing it all up. So this is the drill chuck. We're about to use it to mount it onto the drive shaft of the motors, and this is what spins. And for those that haven't used a drill chuck before, basically you just put in your little key here and you turn it. You don't actually even have to turn it. You can spin it, and as you can see, it opens and closes the little vice grips there, which will seal around the shaft and lock it on. Now once it's locked onto the shaft, of course the shaft will turn it, and much in the same way as a fishing rod works, it will actually take in the line and turn the and pull the camera towards the motor. Of course, if you've got it on angle, it works in reverse, and you can actually let the camera slide out, which is a lot less intensive on the motor, but not that that even matters. These 2 RPM motors are extremely tough. Extremely tough. Okay, now what we're going to do is just actually attach the chuck. So I'm just opening it up to make sure it will fit on the shaft. And once it's on, you can just actually turn it to fix it most of the way. And then once it's nearly on, you can tighten it by putting your key in here. So it's extremely tight now. We've now got our chuck on, which spools our thread. Basically what we do is we feed it through the guide so that it makes sure that, to do that, I've literally just drilled holes in that little bit of steel. But if you do it using my method where I suggest you mount it underneath, you won't have to worry about the guide. If you do it the exact same way that I've done it and you choose to have a guide, you do just have to be careful that it doesn't, if you're using metal as the guide, you've got to have some plastic around it. I just use a tiny bit of thin tube, something along the lines of this. So what I do, just to stop it from fraying the fishing line, or whatever it is you choose to use. So doing that will stop it from wearing on the metal and fraying the fishing line. And when we flick the switch, you'll see that it is pulling the line. You see here that by turning the pulse width modulator, we can adjust the speed at which it's pulling the line to something which is almost imperceptible. Now it looks like it's not even moving there, but I guarantee you it is. And that's the kind of speed that you'll require when you're doing extremely slow time lapses. I'll just point out here the position of the bracket. So I've just drilled holes and put 2 bolts in the side and then just bolted on using just some bolts that I had lying around the house, this L bracket. The holes down here are what mounts into the standard tripod screw slot at the end of your slider, and I'm using this, which came from some old gadget that I had lying around, but I've suggested rather than getting this bit of steel from your hardware store, I've suggested getting L brackets, a pair of them for a flash, which is actually cheaper and will come with one of these, and so you won't have to worry about having something to screw into your tripod 3/8 inch screw hole. On the side you'll see the mounting points for the bracket. You'll also see that I've just drilled a hole to have the shaft popping out. It doesn't have to be particularly neat, as long as the shaft pops out and it doesn't catch on anything. That's all that matters. On the back you'll see some screws from the mounting points from where I've put on the brackets that hold down the motors. You'll also see just where I've mounted on the guide plate, but as I suggested, if you put it there you won't even need this. On the top you can see the USB port, and flicking the switch turns it on. You probably won't be able to see it, but there's actually a blue LED that's on there, and that'll charge anything. In this case I prefer to use it to power my fan. Okay, alrighty, and we're all done now, so thanks for taking the time to watch this video. I hope it's been helpful. I just want to say thanks to all the people who have put forward the original ideas which I've taken and hopefully put together into a slightly more digestible and easy to follow format. So thank you to all those people who actually came up with the ideas, and I've only slightly incrementally improved upon them. I hope you enjoyed, and as I said, let me know if it was useful or you have any questions. Thanks for your time.